Yeah.
An uncharged 5 farad capacitor is connected to a 9-volt battery that has a 1.5 ohm internal resistance. How long does it take for the capacitor to gain a voltage that is 95% of the battery's total voltage? So our givens in this situation are resistance, which equals 1.5 ohms, and capacitance, which equals 5 farads. We start off by finding the time constant tau, which is equal to RC. So we multiply them together, we get a 7.5 ohm farad as our time constant. Next, we use the equation the current voltage equals the final voltage times 1 minus e to the negative t over time constant tau. And since 95%, since the starting voltage of the battery is 9 volts, we just multiply it by 0.95 to find the final, which is 8.55. Plug in the initial, plug in the total voltage, I guess, 9 volts right here, and then plug in the time constant tau. And then when you solve through for it, you find time equals 22.5 seconds.
Okay, so part B for this question is, in the circuit to the right, the capacitors are charged so that they have an initial voltage of 10 volts. At time t equals 0 seconds, the circuit is connected as shown. And part 1 of B is, at what time is the capacitor voltage half of its initial value? So half of the initial 10 is 5 volts. So first, we need to find the equivalent resistance, capacitance, and voltage of this circuit. So to find the the equivalent resistance, you take these two in parallel and add them. 1 over the first resistance is 150 plus 1 over the second resistance is 225, and then you get 1 over the equivalent resistance for these two, which is 90. And then you add, since these are in series, you add resistances in series. So 90 plus the 10 ohms equals 100 ohms of equivalent resistance for the entire circuit. Next, you have to find the equivalent capacitance, and capacitance in parallel is opposite, the math is opposite of resistors in parallel, so you just add these capacitances. So 30 millifarads plus 20 millifarads is 50 millifarads of equivalent capacitance. Since voltages are equivalent in parallel, and each of these is charged to 10 volts, the entire charged voltage, the equivalent voltage, is 10 volts. So next, you have to find the time constant tau. So it's equals RC equals the equivalent resistance, which is 100 ohms, times equivalent capacitance, which is 50 millifarads, and you find the time constant to be tau equals 5 ohm farads. Next, you use this equation for a charging capacitor, or discharging capacitor. So delta V, which we're trying to find half of the initial value, so we're trying to get it to 5 volts, is equal to the initial voltage, which was 10 volts, times e to the negative t over tau, which we found was 5. So when you plug all that in, you get t equals 3.47 seconds for the amount of time it takes to reach 5 volts. Okay. So part 2 of B is, at what time is the power dissipated in the 10 ohm resistor 5% of its initial value? So here are the power dissipated equations. First, we need to find the current running through the 10 ohm resistor. So that's V equals IR, 10 volts, because the equivalent voltage in the whole thing is 10. And then the equivalent resistance in the entire circuit was 100 ohms. You get I equals 0.1 amps for the current running through the entire circuit. So since currents are the same in resistors in series, the current for the 10 ohm resistor is the same as the current running through the whole thing. So the current for the 10 ohm resistor is also 0.1 amps. So next we need to find the power dissipated in the 10 ohm resistor. So power dissipated equals I squared times R, and you find P equals 0.1 watts. Since we need to find the power dissipated in resistor 5% of its initial value in the 10 ohm resistor, we need to take 5% of the power dissipated. We find that's 0.005 watts, and then we plug that back into the power equation here. So to find the current through the 10 ohm resistor when it's 5% of the power. So after we do that, I squared R again, we find that when the power is at 5%, the current is now at 0.0224 amps. And then we use that, and we plug it into the discharging current equation, which is I equals I initial times e to the negative t over tau. So we are trying to find 5%, so it's 0.0224 times the initial, equals the initial current, which was 0.1 amps, times e to the negative t over the tau we found before. And we find t equals 7.496.